So good morning, everybody. I'm happy to see you. I'm very much looking forward to this presentation. Actually, I must say I had one question concerning the topic we were speaking about before, because I think one question of plants cleaning the soil is also which metals you are mainly worried about. Do you know anything? So there are, I guess, different plants with different abilities to accumulate different metals. So I personally would be interested in maybe hearing what might be the chemical composition of the metals, or is that something you might have to look at first before answering more or less what might be the best strategy in this context. But I think for that, yeah, a soil analysis, etc., could be very helpful, of course, in the short term, and then also maybe long run to come up with good strategies. So if I understood you correctly, I will then now take my hand down, and I guess I can start.
I can introduce you really quick. Can I interrupt? I don't know if we have someone introducing Peter today, but
I was already introduced. I think,
you
right?
were already. Okay, yes. Then my job has been taken from me already. So good, go ahead then.
Okay, perfect. And just for my understanding, so the presentation I see on screen now, that is, I don't have to share my screen, right? So we will have the...
Yeah, so in fact, we have this presentation translated, and some slides with many texts, they have two copies, one copy in English and one in Ukrainian. So I'm showing this screen for Ukrainian channel. I think that it would be better if you show your screen and only show the slides in English language, wherever there are two copies of slides in different language.
Okay, so then I will share my screen with you, I assume, yeah? Perfect. So this is step number 1. And... okay. So I hope this works for you. Can you see my screen?
Yes, we can.
Monica, you're shaking your head?
I do not see your screen.
Okay, are you
I can see it. Are you in the right Ansicht? If you choose options.
Ah, yes, you're right.
You have to go into Peter's.
Mm-hmm. Thank you. Thanks.
Okay. Yeah, thank you all. So then I will get started. Like you already heard before, we really delve into agroforestry concepts and some questions of agroforestry in practice. I thought I would just take you on a very, very short journey through history, very short for a very long period. However, yes, so for now we will start with the introduction and the history, actually, of agroforestry until our day at present. So you know, of course, agroforestry as a sector belongs to the primary sector. If we look at different economic sectors, you will know agriculture belongs there, forestry belongs there. You might also know we distinguish other economic sectors, so the secondary sector in which the resources are transformed into some product, tertiary, or the third sector, more or less, which focuses on services. And nowadays, actually, there's even a fourth sector, which is the IT sector. However, as the name suggests, agroforestry is some mixture of agriculture and forestry, and with that, we are clearly in the primary economic sector. I will just move your the video of you guys to the side. Okay. Good. However, before people actually had a lifestyle in which they stayed at one area or in one area, people used to actually have a different economic form in which they would live. which was referred to as extractive economic form. So people would follow the resources and move with their family and their group of people throughout the landscapes in a more or less nomadic style of living. So these are these typical hunters and gatherers. And at some point in time, there became this change from more or less having this extractive economic form of living into a producing economic form. And of course, in the center of the production always was the food production, which allowed the people to produce food locally and cultivate the land around them, domesticate animals, etc., and of course also plants. And then also over time, change these plants in accordance to their needs. So this happened in agriculture very early. However, it also happened in forestry a bit later. And actually the systematic cultivation of landscapes kind of represents a transition of lifestyles, actually. And you know, nowadays, more than 99% of the human population has not anymore a nomadic lifestyle in which they move around through the country, but a sedentary way of living. So staying at one point in space, more or less. If we look back, actually, when this began in our regions of the world, this change of lifestyle is also referred to as Neolithic revolution, and it most likely began in what we refer to as the Fertile Crescent. In German, the word is fruchtbarer Halbmond, and Halbmond is a word which means half moon, and it's related to the shape in which actually the oldest indicators for permanent settlement were found on the Eurasian continent. And you can see where we are. So you can see this is the region of eastern Turkey, Syria, Lebanon, now Jordan and Iraq. And this appears to be the oldest, so far until today, these appear to be the oldest permanent settlements we have in this region. So roughly 9,000 to 12,000 years ago. And indicators, so fossils and bones and also other parts of pottery, etc., give us a kind of an idea how the people were living and since when they, for instance, had domesticated sheep, goats, and you can see also cattle are presented here, and boar or swine. However, the first animal most clearly that has already accompanied humans also throughout their nomadic lifestyle has always been the dog. From here, there must have been at some point people started moving around. So they took their plants, their animals, and started, it's not quite clear through which routes, so possibly through the north of Africa, most likely through Turkey into Europe on the western side, or possibly also on the eastern side of the Black Sea, and brought their knowledge to Central Europe, which back then was still a bit more wild. And like I was saying, the Vikings, of course, are known, and people were living different lifestyle back in the days. And yeah, so the one big question that arises, of course, is kind of what led to this mass migration. It's quite clear that it happened, but there are different explanations for this. And one possibly plausible is something we know from the Bible also, actually being this great flood. You might know the story of Noah in the Bible, and there seems to be a strong indicator that some event in this type must have taken place, And this is what you can see slide. If you look on the right side of the slide, you can see how the ocean rose actually around the year 9,000 before zero, so before our time. What is it? The date since Christ's birth, more or less, so the year zero. You can see how the water level increased at the North Sea, actually, from minus more than 50 meters, actually, up to a level which we have now. So the reason for this most likely is that back in the days, shortly after the ending ice age, the glaciers melted, and the water levels of the Black Sea and around the region, which we call the Fertile Crescent, the water must have risen strongly, and most likely this was one reason that led to mass migration. So certain climate change, of course, then the sedentary lifestyle also allowed the population to grow. And with this, most likely space became an issue and people had to move around their continent. There are actually a few parallel approaches to this around the world that were also independent from one another. So most likely there was also a little cell in what now is China, from where this lifestyle seems to have spread. And also on the North and South American continent, there were also these developments of changes in lifestyle and cells from where this lifestyle spread over the continent. The reason why I'm presenting this is actually that if we look back at how the Neolithic Revolution and of course the following periods affected the way people were living and how they were dealing with their environment, we already find a few parallels to what we consider to be agroforestry nowadays. So of course, at the beginning, the focus was quite strongly on crops people could grow that would deliver them with food. So for instance, peas, barley, wheat, oats, etc. The way these were grown was more or less quite basic. So the people followed the seasons and sowed their corn, etc. in spring. There were actually no winter fruits, and there was also nothing what we refer to nowadays as crop rotation. So to improve after having an intensive crop on the field to allow the field to regain its nutrients, for instance. So situation actually was quite basic. And after the harvest, as you can see, the domesticated animals were led onto the fields, onto the pasture, onto the pasture land, more or less. And this led to natural fertilization. So there was already a combination, more or less, of animals and field crops. And once, however, the soils were depleted, these were simply left and the people moved on. And you will later on see this actually is also one type of agroforestry. However, then in the Roman times, the Romans were actually the group of people that brought the fruits we still cherish and love nowadays to Central Europe. So apples, grapes, oranges. Also, before that, people actually were only eating wild berries next to the field crops they were growing. And you can already see here, so if we speak about apples, if we speak about grapes and oranges, these are plants that grow, these are fruits that grow on plants that are in some way woody. So they are vines or they are trees or something in this area. And back then we can already see that people began combining these tree species with field crops and of course also always with their animals. So animal pasture just continued throughout the time. Also, under the trees that were then found on the fields. Now, the medieval ages from a forestry perspective are quite interesting for us, because the medieval ages were very strongly dominated by forest pasture. So the animals were directly led into forested areas. So forested areas were just considered as wilderness, more or less, as partly also dangerous areas, where not wood production in the sense we think about it nowadays was in the focus, but these were just wild areas. And if you would extract a tree, of course, for wood, this was done, but it was not really regulated in any big way. And the forests were ground in which swine could feed, in which cows could use for pasture, etc. And you can see, actually, by looking at the pictures I'm presenting on this slide, forest pasture was something that began in the medieval ages, but actually lasted until the early 20th century, so shortly before World War I, and also partly after, and only later this was actually abandoned. Nowadays, it's not allowed in Germany anymore. What you can also see next to forest pasture, there are two more terms. The one is litter raking, and the other is pollarding, an approach like pruning of trees. So these were also typical ways forests were used. Here, just a few more impressions to give you an idea. So forest pasture on the right side, and on the left side, you actually see the forest structure as we imagine it to be, actually. So what you see over here is a typical stand, a coppice with standard stands, as we would refer to it. And you can see it has quite an open canopy structure, so a bit more like maybe parkland, something in this direction. And the reason for this is simply the large animals that would move through the forest and would eat away the regeneration. And with this, forest landscapes, most likely where they were used as pasture grounds, were a bit more open than the high forest systems we nowadays see if we go through the forests. And here, just a few more impressions. Also, you can clearly tell these are photos. These are no drawings. So also here we are in the 20th century, and you can see typical forest use forms of these times, in which people would rake litter literally out of the forest, or also carry out the humus layer of the forests, and use the litter and the humus layer as fertilizers for their fields. This especially happened in areas where the soil properties were not as good. So you can imagine on soils where that are already rather nutrient poor, this forest use actually depleted the forests more or less totally of their nutrients, and transported these nutrients onto the fields. So the forests actually, kind of devastated. And nowadays, this area in Germany still has soils that are extremely sandy soils with very low nutrients. And at the moment, actually, I'm in the area where you can see these soils in Brandenburg, so in eastern Germany. However, this was, of course, as a fertilization form, this worked rather well. And you can also see in the top right corner of this slide, you see coppice forests. So also a typical forest structure as we imagine it to be in forest situations in which the main focus lies on energy wood. So nobody was interested in large tree diameters, because these were hard to handle. People were interested in small diameters you could directly put into the oven, and the focus was very strongly on species that would resprout from their stalks. So birch, for instance, willow, of course, poplar trees, etc., that are able to do this. And of course, also oak. Here are just a few more impressions of this technique I refer to as pollarding. So also here, actually small young branches are cut from the trees and used as winter fodder for the animals. So they were then dried and brought into the stables and were used as fodder. And then after the remains of the stables were also collected and brought back to the field, again, as a fertilizer. Okay, and now we're getting a bit closer to where we are at present. The late 19th and 20th century were also characterized by an intensified urge to control nature. So I was telling you before, forest areas were considered as wild landscape, and the idea was to tame this wilderness and to turn it into land that could be used by the humans. And this is kind of indicated by this figure that you can see here, which is actually a figure for a certain region of Germany, and you can kind of see how the heathland, etc., was changed into land that could be cultivated or land that was afforested, so for wood production or food production. And yeah, over time, the amount of bogs and heathland, etc., decreased until the land was more usable for the humans. And this drive to order, of course, was also quite strongly influenced by the industrialization. So when the first machines came up and were developed, the first tractors, for instance, were used in the US. This again very strongly changed the way that agricultural sites were managed, and with the option to use chemical fertilizers, this also strongly changed the ability of how sites could be used for agricultural purpose, of course. And what this is often referred to, or this time span starting in the 1960s, 70s, more or less, is the so-called Green Revolution. However, it's not really green in the sense as we want to understand the term green nowadays, but the term, so not really an ecological revolution, but it changed the green environment in form of a revolution. And the strong drivers of this, like I said, were, of course, the science and industry that kind of pushed the borders of what is possible in agriculture. This revolution benefited from fossil energy, which was partly rather cheap. The option to produce fertilizers, so chemical agents that supported agriculture, on the one side by fertilizing, of course, on the other side also as protective agents, so poisons to crop damaging insects, etc. And with tractors, there were, of course, new options of how the land and especially how much land could be managed by single farmers. And the hope of this Green Revolution was, of course, that the situation in the world, so poverty, hunger, etc., could be tackled and improved. And as we know nowadays, a lot of areas have strongly improved in view of their wealth. However, the areas that were to be supported, so parts of Africa, parts of South America, etc., did not benefit from this development as much as possibly intended. Also here, just a short overview of what this Green Revolution more or less meant. So back in 1900, if one farmer on average fed 4 people. Then in 1915, this has already more than doubled. So 50 years later, one farmer would feed 10 people. And yeah, nowadays we can assume a farmer feeds about 150 people, a single farmer. And the prognosis is that this will continue. And possibly in 2050, a farmer will feed 200 people at once. And this is all simply based on these improvements, if you will, of technology and of the understanding how fertilizers, etc., work on the fields. And in Central Europe, especially also in many parts of Germany, this Green Revolution also very much changed the landscape. So, like I was trying to stress before, the agricultural crops and woody components, etc., were actually found on large parts of the countryside. So especially woody crops were often used also as boundary markings around fields, etc. And this Green Revolution led to a field being economically more interesting the bigger it became. So this typical economy of scale. So if you make use of heavy machinery, etc., it becomes more and more effective the longer you can use this without, for instance, without having to evade structures like, for instance, woody components in the landscape, etc. And this actually led to the fact that all these elements were removed from the landscape. So there was a rather strict separation, which we still can see nowadays between forest areas and agricultural sites. And the agricultural sites were actually characterized by not having too many obstacles or structural elements on them anymore. So fields, individual fields became bigger. Like you saw, of course, also the amount of farmers strongly decreased that were managing this land, and single farmers had larger fields they were working on. Yeah, and of course, as a little summary, of course, this so-called Green Revolution has massively improved the food situation for large proportions of the population around the world as a result of these better machines, the infrastructure, the better seeds that could be used, and of course the options of fertilizing and watering the sites and using chemical pesticides. However, now, of course, we also know that this Green Revolution causes serious environmental damages through, on the one side, of course, all the factors that somehow affect biodiversity, so homogenization of the field crops, the simplification of the systems, so large monocultures, and around the world, of course, the resulting or the required deforestation also to make space for this kind of land management. Then, of course, there are all the risks of monocultures in agricultural systems. This is not such a big deal because you're just looking at a field crop that grows for a year. In forestry, this is a much bigger problem that we are facing at present in monocultures, for instance, of spruce, which cannot deal with drought, and then the heat waves that are often accompanying this, and then the bark beetles that follow after. Also, the Green Revolution, like I said, it's called green, but not in an ecological sense. So questions of sustainability, etc., at the beginning of the Green Revolution, of course, did not play a big role. So soils were depleted because you could then use chemical fertilizers to simply improve the soil conditions again. But of course, this is not a sustainable way of land use. And the consequences of this, of course, desertification and also soil erosion and environmental pollution of water, of soil, of air, etc. And nowadays, of course, the big topic, climate change, which is also strongly driven by changes in agriculture. And this brings us back to agroforestry, or the way agroforestry is actually seen today, because people nowadays say what we need is a greener revolution. So not another green revolution, but a greener revolution. So one that is focused on ecological aspects of agriculture. And within this framework, digital farming, smart farming, etc., are topics that are often mentioned, which simply means combining agriculture with technological aspects of IT, for instance. And this is why agriculture, or this way of land management, is also called agriculture 4.0. If you remember back when I was speaking about the economic sectors, the fourth economic sector is the IT sector. So all the technology around robotics, artificial intelligence, sensor technologies, etc., is already strongly being used in modern machinery that is in place in agriculture at present. However, as an outlook, actually this greener revolution is hoping that we can slowly move away from this economy of scale, so from the large machines back to smaller machines, drones, robots, etc., that will also be able to manage the countryside in a economic sensible way, but also allow thinking in smaller structures again. So as indicated in this picture in the bottom, maybe, so structures in which we can increase the share of woody components, for instance, and the structural diversity of these systems, and be productive nevertheless on the other side. So with this, there is the possibility that the importance of agroforestry could increase again strongly on a global scale. Okay, so maybe this so far as a short introduction into agroforestry. The problem here on my screen is that I cannot see you as long as I don't look at you. My question would just be, can you still hear me? Is the connection okay so far?
Yes, we can hear you well.
Perfect. So now we will look into agroforestry in a bit more detail. First, like always, starting with a few definitions and looking at general concepts of agroforestry. At the moment, actually, there are, or is a large variety of definitions of agroforestry around. I don't want you to read all these definitions, of course. I just want to highlight a few points that we find in these definitions that seem to be reoccurring. So land use systems in a certain way, management of land, etc. Then we always find the fact woody and agricultural or pastoral species that are included, agriculture and forestry, shrubs, trees, etc. Then we can see, actually thinking about the concepts, there are already hints in most of the definitions in view of some kind of mixture of these in a temporal sense, in a spatial sense, etc. So somehow combining these. And finally, the aim of agroforestry is somehow to increase the total productivity or maximize the benefits, as you can also see, or somehow optimize the system. So if we simply summarize this, what is agroforestry? Then we can say agroforestry is a land use system in which perennial woody crops and or trees are combined temporally or spatially with annual crops and or livestock on somehow the same production site. And the hope, of course, is that by combining these, we will have some advantage of the system in relationship to not combining this. So in comparison to a monoculture of a field, for instance, and a separate forest. So if we remember what we just spoke about in a historical context, then like I said, actually back in the days, forestry and agriculture somehow was not strictly separated from one another. Then over time, where forest management also became more advanced, like I said, first it started in agriculture, then it moved to forestry. There was, of course, a certain differentiation, which we still see nowadays. And now we are actually at a point in agroforestry landscapes in which we again want to merge these two into a new land use form, which is the agroforestry land use. So agroforestry is nothing new. It's somehow a rediscovery actually of a historic land use form. Now I want to look at a few concepts, like the general groups of concepts that we differentiate in agroforestry. You already hear these different terms. So agri, of course, somehow stands for agriculture, comes from the Latin word agar, which stands for field or free land. Silvicultura, silva, you will also know this maybe from Latin, which stands for tree, forest, or shrub. Then we have this pasture, and in Latin, the shepherd. You will maybe know this also from in a Christian sense, the shepherd and his sheep. So the reference to the church, of course, but actually we, in this sense, of course, are thinking about animal husbandry, animal production, etc. And cultura, this word that simply stands for taking care of, cultivating, landscape, etc. So agriculture, silviculture, cultura always is in these terms. And nowadays, actually, we distinguish three big agroforestry concepts which somehow combine these words. So agri-silvicultural systems are systems in which we are combining woody components with agricultural field crops. Then we have silvipastoral systems on the other side, which are combining woody components with livestock and herding. And then, of course, we also have the combination of all three aspects, which are agri-silvipastoral systems, in which you have the woody components, the field crops, and you have livestock in these systems. And here are just a few impressions how you can imagine this to be, or how this possibly can look. Agricultural systems, on the one side, we see a strip-wise mixture on the left, in which we would nowadays refer to as alley cropping systems, even though the original of the alley cropping, I'll get to that later, actually had a different background. And on the right side, you can see a system in which we have an area-wise mixture of valuable hardwood that is being mixed in this case with a field crop in the understory. Silvipastoral systems typically maybe something in this direction. So the trees providing shade, partly also fodder, for instance, for the cattle, or also other animals that can be used on these sides. So the trees have some kind of providing function for the livestock. And here, this is maybe not the best image, but you can already see what happens if you want to combine all three elements on the same area. You can see on the left side of this picture, you see a fence. And this already indicates that if you want to combine livestock with field crops, you cannot work with so-called simultaneous systems, because of course the livestock would damage the field crops. So these have to be separated from one another in space and in time. And then there are a few special forms that are also referred to as agroforestry concepts or systems. So the apisilvicultural systems, in which actually bees are combined with trees. You might have heard a bit about that yesterday. And the aquasilvicultural systems, here you can see a mangrove system in which the trees also have a servicing function for the production of fish. And of course, in all these cases, these are just very general concepts. Partly you also have smooth transitions or mixtures of these systems on the same sites. So if we kind of want to summarize a few of the properties that these agroforestry systems have, then we can say they always consist of 2 or more species. So monocultures in agroforestry are not possible via definition. They always consist of different plant species, or at least one plant species with animal species. They always have this element of a woody species. So the second term, forestry, agroforestry, is always part of each of the systems. And one of the products that is being produced in these systems is being produced over more than a time span of a single year. And just by looking at this, monocultures in comparison to this, at least bicultures or crops with even more species, we can already see that these, or the management of these systems, must be in some way a bit more complex, but also their ecological interactions will be more complex than their monocultural counterparts. And now I just want to look at a few ways how these concepts, again, can be differentiated from one another. So I already mentioned the simultaneous mixtures and the sequential mixtures or systems. So depending on which components you combine in agroforestry, this might require either the one or the other. Simultaneous systems, on those sites, the components are intentionally combined at the same time in the same space because you want them to interact with one another. So the management objective of these simultaneous systems is to actually maintain all components throughout the whole production at the same time. Sequential systems, in these, as the name more or less suggests, the aim is that the components replace one another over time, so they are possibly combined simultaneously for a certain time period, but then replace one another. So a typical example for this could be a successional system, for instance, in which you start out with a certain group of species, and over time this species composition changes and species replace one another. Then another way how we differentiate these concepts from one another is by the way the components are combined. So are they combined in sections, which would be typically strip-wise mixtures? You have one strip of woody components, field crop, woody components, field crop, etc. Or are they combined over the area, over the whole area, more or less equally mixing the different elements with one another? So also here, the aim of the stripwise mixtures, of course, is somehow to separate the components along certain structures. They can be linear structures, but they can also follow, for instance, natural structures, so water flows, or also if we think about elevation, so elevational lines, for instance, etc. And the aim here of the woody component often is, of course, to somehow protect the field crop, for instance, against wind, against water, so against erosion in general, but also not interfere too much with the field crop. So the woody component kind of provides the service function in a punctual way at one point within the system. And the opposite is true for the area-wise mixtures. So there is actually, the idea is no spatial separation, but to evenly mix the components, as I mentioned. And here, the aim is that the woody components provide a function equally across the whole area. So, of course, this can be some protection against climatic extremes, which could be protection from radiation, protection from cold temperatures, so to level out the temperature extremes over the area. But it could also, of course, be providing function not above ground, but below ground, for instance, by increasing the soil fertility equally over the area. So the idea is to provide a function across the whole production side, more or less equally. And then there are a few more. I'm just going to mention them, so you have heard them. So the functional differentiation, in which we have, on the one side, have productive systems, so where the wood actually creates a product that should be used, food, fodder, of course, wood for any kind of energetic use, and the rather more protective systems where actually the function of protection is the main function the system should have. So against abiotic factors, but also, for instance, just as obstacles to hinder or prevent that the area can be accessed. And finally, looking around the world on a global scale, we could also differentiate the concepts by their economic and technical standards. However, I don't want to go into details here, but the bigger the systems get, we differentiate between commercial systems, intermediate systems, and subsistence systems. And the aim of these changes, of course, in commercial systems, the focus is on cash crops. So on field crops, you can somehow make money with. On tree species, you can make a lot of money with, of course, etc. And the opposite would be the subsistence systems, in which the level of technology is a bit lower, and the main purpose of these is to produce food and possibly also energy for personal consumption, so to satisfy basic needs. As I mentioned before, agroforestry is characterized by mixing. So by combining different elements with one another. And by doing this, you will always run into the situation that these elements somehow interact with one another. And this will just be a short outlook on this aspect. So if we think about at least two species systems, the aim of agroforestry actually is to find beneficial combinations in nature and to copy these, so biomimicry if you want, and to copy these and to actually integrate this biological automation that takes place between the species without you requiring further management, to integrate this into the management of the agroforestry systems. And the hope is that you get these beneficial effects between the components, which then should somehow optimize your system in relation or in comparison to a monoculture, as I mentioned before. If you think about plants and animals, you know they are always interacting with, on the one side, environmental factors. These are the abiotic factors. If we think about plants, this will be nutrients, this will be water availability, of course, somehow with their temperature, and of course also with light. So these are the four key factors, as you know, for plants that are important. But they don't only interact with their environment, they also interact with other living beings in the ecosystem. And the interaction for plants, as they are stationary, they can't move around. But what makes them stationary is that they live above ground and they live below ground. So that is also where the interactions take place, above and below ground. And a centerpiece of agroforestry systems is to kind of and understand these ecological interactions and their impact on the components that are being used within the agroforestry system. And you most likely will all know this from your biology books. However, just as a short summary, like I said, the interactions with abiotic factors are more or less the basis of plant growth. So wherever it's too hot or too dry or too cold, etc., plants cannot grow. So there are there is a certain combinations of interaction that has to take place as a basis for plant growth, which we refer to as these growth site conditions, environmental conditions, in combination with the resource availability. But if we look at the biological interactions in ecology, then you will all know these can be negative, in some way neutral, or positive. And they happen, of course, on different levels all the time between individuals that are interacting. And in agroforestry systems, of course, the focus should lie on the in some way positive interactions. So the typical symbiosis, or also a parasymbiosis or parabiosis, in which one component benefits the other one, however, does not have any negative effects by the other individual. So looking at probiotic systems and identifying these for agroforestry is a very important point. And like I said, agroforestry systems make use of these interactions with the hope that so-called mutualistic species can be combined so that they benefit from one another, or the other term important in this context is the complementarity, so that the species don't get into one another's way. So that they, for instance, if we think about the below ground interactions, you might have species that have very flat roots in combination with species that have a deep rooting system, for instance, so they don't really compete with one another in the soil ground. But of course, all interactions often are also accompanied by some kind of competition. So we're speaking about plants, they all need the same abiotic factors, etc. So competition usually does also take place, which would be a rather negative interaction. And it's just important to keep all these possible interactions in mind when managing the systems. So to wrap this up, the expected positive effects that we have, so the reason why different components are being combined, and especially why woody components are being used on fields, if you want, is that we hope that the woody components are able to increase the soil fertility. This can be by their litter, this can be as a result of pruning, for instance, this can be because their roots penetrate the soil and increase the soil properties. And of course, in a lot of agroforestry systems, leguminosis tree species are being used that are able to fixate nitrogen in the soil. And finally, a last point, also erosion control in a lot of areas also plays a big role, so that the trees more or less hold on to the soil and reduce the effects of wind and water erosion. The aim is also that the trees are able to increase the water holding capacity of the soil. And for instance, by filtering, also possibly the groundwater quality can be increased. The microclimate is another point, of course, that is strongly affected by a canopy cover or by trees in the landscape. So usually it will have some kind of protective or buffering effect. And then the whole area of biodiversity, of course, so by increasing the structural diversity of the systems, the hope is also that habitats are being created, which will then increase the biodiversity on a landscape scale. And yeah, one last point, maybe also nowadays, of course, the carbon sequestration plays a big role. So trees as elements that capture carbon are, or this is another reason why agroforestry systems currently are promoted. But like I said, there are negative effects through competition, of course, so shading will more or less always occur. It can be for certain field crops that grow well under shade, it can be positive. But in general, of course, shade takes away light from field crops, and trees will most likely always, or woody components always outgrow the field crops, so they will be shading them. Competition for nutrients and water, of course. There are partly these effects referred to as allelopathy, so one species having a negative effect on another species, for instance, by releasing chemicals above ground or below ground in some kind of way, can happen. But partly this effect is even also used in agroforestry systems as something positive, so to get rid of species you do not want into the system. And if we look around the world, a possible further negative effect can be that in many agroforestry systems, exotic tree species are used. So non-native tree species that always, or what always is somehow accompanied by a certain risk. So by introducing a new species into a system, it can also result in the replacement of native species if a non-native species turns out to be invasive. And in a lot of cases, if you think about the positive effects we want in agroforestry systems from the woody components, these are actually species that have a strong potential of becoming invasive because they should change the soil properties. They should, for instance, fixate nitrogen, etc., etc. So this is something at least to consider also in agroforestry systems. So to summarize this, also here, we can say that the negative interactions kind of set a certain limit to the agroforestry systems, but the positive interactions, of course, offer much potential. And on this slide, I just brought you a little example, more or less, of what actually happens in every agroforestry system. So if we sum up the negative and the positive effects, you always have a certain trade-off taking place. So you have the intention of integrating one component in the system to get a positive effect, but usually it also brings a negative effect, and this is the trade-off. And as long as the positive effect outweighs the negative effect, then it might be beneficial to nevertheless combine these two species, for instance, because the whole system will benefit from the positive effects. And you can see here on the slide a system with a field crop that is combined with the Anna tree, Valdivia albida. And this Anna tree is actually able, so it's also a leguminosus species, it is able to fixate nitrogen in the soil, so it changes the soil properties. And these changes in soil properties lead to a decrease in the abundance of the root parasite, Strega hermotica, which damages the field crop. And you can see this trade-off effect actually on the bar plot that is presented on this slide. So you can see whenever the field crop is close to the rows of Anna trees, so they are mixed in strips into the system, you can see that the productivity also of the field crop is a bit lower. And this is simply because of the competition between the woody component and the field crop. But with increasing distance from this, so in 6 to 10 meters, also in 11 to 15 meters, we can see that the productivity increases strongly, and you can see that the intention of combining these two species is achieved by looking at the crop vigor. So the vitality of the field crop is higher because the infestation of the root parasite is much lower. And then you can see the two bar plots on the right side of this figure, a situation of a monoculture that is infested. So we can see the productivity is extremely low, but also the productivity of a not infested field is lower than the maximal yield you can achieve by combining or by also getting this fertilization effect of the Anna tree. So we can see here that the mixture, the agroforestry system, is beneficial in comparison to the monoculture. And this is one thing we will not go into detail, but just to give you a rough idea, of course, how the interaction between the components in agroforestry can be affected. So while looking at the concepts, you already got an idea. Of course, you can choose different planting designs, so in rows or strips in relation to area-wise mixtures, for instance. Of course, how these lines, if you plant them in lines, are placed in their orientation, so their alignment plays a role. How much, for instance, light they take away or don't take away. Then, of course, interactions are related to the species that are chosen. Above ground woody components can be shaped through pruning, cutting, or shaping the crowns, but also below ground interactions, especially rooting patterns, are shaped in agroforestry systems by also pruning the roots, for instance, so that the trees are forced to drop their roots into lower soil layers.